The next quadrilateral we're going to be covering are kites, and this will be the last type of quadrilateral that we're going to cover for this unit. So let's go ahead and look at some of the properties. But first, we're going to go ahead and cover what the definition of a kite is. So as you can read here, the definition of a kite is when you have two pair of consecutive congruent sides, but their opposite sides are not going to be congruent. So what's important here is that we look at the consecutive sides. So we're going to look at the sides that are right next to each other in the kite, and those two sides, each of those pairs will be congruent. So they're going to have the same length. So let's look at the diagram here to visualize what the definition is saying. So here's a kite. With kites, we don't have parallel sides. So I'm going to go ahead and outline one of the pairs that are going to be congruent, which are the ones that I did in green, and then the other two pairs of sides will be congruent. So unlike your other parallelograms where the opposite sides were congruent, it's not true for your kites. So here I've highlighted the pair of sides that are congruent to make them more obvious. And then from kites, we're going to be able to use two theorems here. The first one talks about their diagonals. So if you have a kite, then the diagonals are going to be perpendicular. Just like your diagonals for your rhombus, perpendicular, same thing here. So perpendicular means that they're going to form a 90-degree angle where they intersect. And then the other theorem that we're going to be able to use is that there is exactly one pair of opposite angles that are going to be congruent. I'm going to go ahead and highlight in this example which angles are congruent. And the angles that are going to be congruent are the ones that are going to be in between the two sides that are, the two pair of sides that are congruent. So using those theorems there, we're going to be able to find some measurements of some angles and some measurements of some sides for a kite. In this particular example, we're going to look for the measurement of one of the angles on this kite. So to do that, we're going to use some other theorems. We have a quadrilateral. So a kite has four sides, so it's a quadrilateral. So that means we're going to be using the fact that a quadrilateral has a sum of interior angles that's 360. So I'm going to go ahead and create some equation using that fact there. So if I add up all the angles here, which is E, F, G, and then D, then I'm going to be able to set this equal to 360. And when you guys are naming your quadrilaterals or setting up your equations, it's better off to go in order, meaning do a full circle. So don't skip from one vertex to the opposite side. So I'm going to go ahead and replace the angles that I know the measurement of. So we know angle E is 115. So that's going to get substituted with 115. We don't know what angle F is. So I'm just going to leave it as the measurement of angle F. And we also don't know what the angle G is. So same thing, I'm just going to leave it as the measurement of angle. Actually, we do know the measurement of angle G, 73, but we don't know the measurement of angle D. So we're just going to leave it as the measurement of angle D. And all that sums up to 360. Just like you would normally solve equations, we're going to go ahead and combine our like terms. So our constants 115 and 73. Which will give you a total of 188. And then the other measurements, I'm just going to rewrite them because I don't know what their measurements are. And then we're going to use inverse operations. So we're going to subtract 188 from both sides. And that gives you 172. But we do know, and as we label in our diagram, that these two angles are congruent by that theorem that we stated earlier. So if they both measure the same thing, all we need to do is divide their sum by 2, since they have the same measurement. So we're going to take half of it, and then that will give you a measurement of 86. So this is how you would find the measurements of one of the sides that's missing.